In this example, we're going to solve this linear system by using substitution. So the first step in substitution is to choose one of these equations and go ahead and solve the equation for one of the variables. So typically we're looking for a variable whose coefficient is either 1 or -1, something easy for which to solve. So my coefficients here are -2 and 5, and down here my coefficients are 1 and -3. So this x is almost all by itself already, so I'm going to go ahead and use this second equation. So x minus 3y equals 9. I'm going to go ahead and add 3y to both sides, and that will give me my value for x, which is 3y plus 9. So now I know whenever I see the variable x, I can kind of associate that with this expression 3y plus 9. So what's going to happen is I'm going to take this 3y plus 9, which is equivalent to x, and I'm going to substitute him in to x, but in the other equation. So in this manner, we can combine these two equations together. So I have a -2x plus 5y equals -17. And for the x right there, I'm going to go ahead and substitute 3y plus 9. So 3y plus 9, and then I'll go ahead and write the rest of that down. So it looks like I need to distribute here in order to solve for y. So -6y minus 18 plus 5y equals -17. I can combine my y's together to get a -y, and I'll add 18 to both sides to get 1. So I know that -y equals 1. So if that's the case, I know that y is -1. Now that I have the value for y, I'm going to plug it back into one of these equations to solve for x. So which equation would be best to substitute it into? Well, if I substitute it into either of these two original equations, I'm going to have to do some work to solve for x. Here, I've already done that work. X is already isolated in this equation. X equals this business right there. So I'm going to go ahead and substitute my y equals -1 into this equation here. X equals 3 times y, and y is -1. So x equals -3 plus 9, x equals 6. So now I have a value for x and a value for y, and that will be my ordered pair, 6, -1. And this is the solution for this linear system, and I found that by using substitution. So what that means is, if I was to graph these two ordered pairs, I would see that their single point of intersection would be this ordered pair, 6, -1.